Hi, in this video, we're going to explain another category of function called the piecewise defined function. So let's define first piecewise defined function. A piecewise defined function is a function defined by using more than one expression. So uh, unlike the other functions that we've already discussed, this one is a little bit different because this piecewise defined function is that function that uses more than one expression. For example, if we have number 1, let f be a function defined by these three expressions. So first, f is defined by f of x equals x minus 1 if your x is less than 3. So the domain, if your domain contains all of x that is less than 3. The function f is defined by f of x equals 5, that's a constant function, only if your domain contains only x, which is 3. And your function is defined by f of x equals 2x plus 1 if your x is greater than 3. We will determine the domain and range and sketch the graph. So as you can observe, f here is called piecewise defined function because it is actually defined by more than one expression. In this case, we have three expressions. So as you can see, this is a linear. This one is function f is a linear function if your x is less than 3. Your function f is a constant function which is equal to 5 if your x is only 3, that's equal to 3. And again, this is a linear function. Your f is a linear function defined by 2x plus 1 if your x is greater than 3. So let's try to graph. So remember, we have 3 here as our boundary, right? So if your x is greater than 3, so let me draw a boundary here. Okay, it's not straight. Okay, if your x is less than 3, so if your domain is this one, then your function is a linear function defined by f of x equals x minus 1. If your x is equal to 3, then you have a constant function. If your x is greater than 3, so you have another linear function. Okay, if this is the domain. So first, we will graph this one. Okay, considering only x's that are less than 3. So we will only show the graph of this function in this part of the coordinate plane. Okay, so how do we graph this one? So there are many ways to do that, but one way is first we're going to use f of x is equal to x minus 1. Remember, only if our x is less than 3. So to do that, let us first let x be equal to 3, and let's see what's the corresponding value for f of x. Actually, we're going to pick 2 points, okay, so that we can connect the line. So the first point is we're going to select okay, we're going to select 2 points, okay? First point is the point that corresponds to 3 to the boundary, and the other one is somewhere here, okay? So you pick 2 points. So first, we will pick a point in the boundary. So that is 3. Okay, so we let x be equal to 3. So that is f of 3. So that's 3 minus 1. So that is 2. So if your x is 3, your f of x is 2. So we have 3, 2. So we have 1 point already. Okay, we pick another point in this domain. Okay, we pick another point in this domain because we're only to consider all those x's that are less than 3. So let's say I pick 0. So we let x be 0. So that becomes f of 0. So that's 3 minus 1. So I'm sorry, it should be 0 minus 1. Okay. Okay. 0 minus 1. So that will be equal to negative 1. So if your x is 0, your f of x is negative 1. So we have another point. So this will be enough. We already have 2 points. So first we plot 3, 2. Okay? So we plot 3, 2. So 3, 2 is here. But we are not going to uh, plot this point in solid circle. We only plot this one using only a hollow circle because 3 here. Okay, so x here, so the value of x here does not possibly include 3. Okay, because it's not equal. Alright, so meaning although we consider 3 here, but that's 2, so that's 3, 2, but we will not plot this one using a solid circle since 3 here is not part of this restriction. Okay, so the other point is 0, negative 1. Now 0, negative 1, it's here. 0, negative 1, that's it's located here. So we have a point here. Right, so that's 0, negative 1. So we are going to connect the 2 points. Okay, let's say I use the red. Okay, now actually the graph of this function f defined by this is actually this one. Okay, but we are not including this part of the graph because it's not part of the domain. So since this portion right here is those x's that are greater than 3, including this one. Okay, we will not show the point or plot the point here as a solid because 3 is not included in this domain. Okay, next is we are going to use f of x equals 5. So this is a constant function. So remember, f of x, that's equal to y. So remember, y equals 5 is a horizontal line that is that's passing through 5 in the y-axis. Okay, so now we are going to use that definition of the function f, that's f of x equals 5, only if your x is equal to 3. Okay? So if your x is 3, then if your x is 3, then your f of x is 5. So it's here. Actually, the graph of this one, if the domain is the set of all real number, it looks like this. Since we are only to consider domain which has only one element, which is 3, so which means that we are going to only plot a point that is only a part of this line. Okay, the part of this line. So we are going to put a solid line, a solid point, which indicates that it is really the only part of the line that we are going to plot for f of x equals 5. So which means to say that we are going to plot that one. So that's the only part of the line f of x equals 5 that we're going to plot, since we are only to consider x equals 3. Not x equals less than 3 or x is greater than 3, but only x equals 3. Okay? So we've already plotted the point or the part of the graph. And for number 1, we've already demonstrated that one. And finally, we have f of x equals 2x plus 1 only if your x is greater than 3. So if your x is greater than 3, then this is then the function f is defined by 4x equals 2x plus 1. So to do that, we expect that this function f here is actually a line, because this is a linear function. So we're expecting a line here. Now we will use this boundary right here, just like we did in this line for this function. We will use the boundary so that we will know where do we start. Okay, where do we start graphing? So again, we pick 2 points. Since this is a line, f of x equals 2x plus 1, so we only need 2 points. All right, so that would be enough. Now first, we are going to let x be equal to 3 to the boundary, right? We will use the point in the boundary. So that is x equals 3. So substitute. So we have 3. So 2 times 3 plus 1. So that is 6 plus 1. That is 7. So if your x is 3, then your f of x is 7. Okay. Next is you pick any. Now, since this is the domain that we are only to consider, now you can pick now. You're free now to pick any point. So let's say I pick 4 to make it simple. So I let x be equal to 4, since again 4 is greater than 3. All right. So yeah, so substitute 4, then 2 times 4 plus 1. So you have 2 times 4. You have 8 plus 1, so 9. So if your x is 4, your f of x is 9. So we have 3, 7, and 4, 9 as our points. So let's graph this one. Or let's plot. 3, 7 is located here. 3, 7. But we will not use a solid line because 3, remember, is not included in as our value, possible value of x, since this is not equal to. All right. So again, we will use a solid, a broken or a hollow circle. And then 4, 9 is 4, 9, it's here. So we will connect those points and then you'll have a line. Okay, so let's say I use the green one. 3, 7. So 3, 7. So I'll just put a hollow line circle. And then 4, 9. So for 4, 9, it's here. So I use the solid now because 4 is already included in the domain. So remember the domain. So just connect because this is a line. Okay. So I'll just connect these two points so that we can form a line, because by definition in geometry we only need 2 points to determine a line. It should be a line. So now I will erase this boundary thing. It will only be our guide. And so this 3 graphs right here in our xy plane is collectively the graph of our function f, so which depends on our domain. So now the question is, how do we determine the domain? So it's quite easy. So that's the next question here. So the domain now, the domain of the function f, so the domain of the function f is the set of all real numbers, because you can use all those numbers here, including 3 as well, and all those numbers that are greater than 3 in our function, so as our values of x. So those are the permissible values of x. So the domain is the set of all x such that x is an element of real number, so any real number, or in other words, that is this one, or in interval notation, that is this one. How about the range? Okay, so the range of f is, okay, observe that, so what are the possible values of f of x's? So we collect all those and then we can form our range. So now for 7, so not including 7 because it's hollow, so meaning not including 7 but all those numbers greater than 7 only. 5 because it corresponds to this point, and those numbers not including 2, only those numbers that are less than 2. So we have 3 sets of numbers that we are going to see, 3 sets of numbers that we're going to combine. First, all those numbers that are greater than 3, 5, and those numbers that are less than 2. So which means to say that, yeah, 7 and all other numbers here in between, this 7 right here, including 7, and not including 5, so meaning those y that are in between 7 or equal to 7 and 5 are not included, and those in our range, not included in our range, and all those numbers not including 5, but includes 2. As you can see, it includes this one. So all those sets here, okay, is not included in our range. So again, we have 3 sets that we're going to combine, so you use the union as our operation. So first, all those numbers, all those y's, or those numbers that are less than 2, so this one right here, okay, not including 2, that's why there's no equal in there. And then we're going to union it with a set that only includes 5. And then when you're going to union it with all the numbers not including 7 but greater than 7 and greater than 7. So all those y such that y is greater than 7. So this is the range. Okay, so you can use the interval notation. So this one can be written like this, and then union of 5, and then union of from 7 up to positive infinity. You can use that as our notation. So that would be the range for our f, function f. So please stay tuned for the second part of this video for another example of a piecewise defined function. How do we graph them? So that would be all for this video. Thank you very much and have a nice day.